Hey everybody, let's talk about adding positive and negative integers. And remember, integers are just whole numbers, and we're starting there because it's easier than starting with fractions or decimals. So what we're going to do is just add some whole numbers, just like back in the day, right? Now, you never really thought about this before, but when you were in school learning 3 plus 4, what you were really doing was learning how to add positive numbers. So let's take a look at 3, and we will add 4. And both of these numbers are what we would call positive numbers. And I'm going to represent these two things on the number line with what we call vectors, right? So let's always start at 0. And I'll represent the first number, 3, by graphing a line in the positive direction, because it's positive 3. And I'll make that line go 3 units in the positive direction, right? And we call this line a vector because it has a size, or a magnitude, and a direction. The direction is positive. And what I'm going to do is add another vector to that, right? So we started going positive 3 steps, and now we're going to continue with another vector that goes 4 steps in the positive direction. 1, 2, 3, 4. And when these two arrows are going in the same direction, we're just going to simply bind them together or add them together, and they will create one large arrow, right? And it's going in the positive direction, and it goes from 0 all the way to 7. And that's how we can say that 3 plus 4 is 7, right? Now this works in the opposite direction also. Let's see if we can add two things that are negative, right? So what if we started off with something like negative 3, and I'm going to add to that another negative number. Let's call it negative 4. I'm going to put it in parentheses here, not that that means anything special, except it's separating the plus sign from the negative sign, right? So this just says negative 3 plus negative 4. On the number line, that would be represented by these two vectors. I would start at 0, and I would head to the left 3 units. This vector has a magnitude of 3, and it's heading to the left. That's the negative direction, a magnitude of 3 and a direction of negative. And I'm going to add to that another vector going in the same direction, except it's going to go 4 steps, right? So this has a magnitude of 4 and a direction of negative. And when I bind these two things together, they're just going to make one large vector. If I add them together, it would just make one large arrow pointing in this direction and going from 0 to 7. And that's how we can say that negative 3 plus negative 4 equals negative 7. Pretty straightforward, right? There's a rule that we can use. When the signs are the same, right? Same sign, and by sign I mean positive signs or negative sign. If I'm adding two terms that have the same sign, we're going to keep the sign. Those two arrows are going in the same direction. They will make one big arrow going in that direction. We will keep the sign and add the magnitudes or absolute value. My writing is not working so well. The pen is jumping around. We will add the absolute values. And that is a simple rule for adding numbers that have the same sign. Keep the sign, add the absolute value. Most of you already knew that already. Let's just keep going and see where things get a little bit tricky. Let's go to the next problem here. Here we go. Adding with opposite signs. This is where it gets a little ugly. So what if I have a positive 7 and I'm adding something with a different sign, like say negative 12. All right, so let's take a look and see what that looks like. All right, so you know the first part. We're going to make a vector in a positive direction, 7 steps. Okay, boom. I should probably boom, 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 boom. There we go, 7. And now instead of making an arrow that is going to continue in that direction, we are going to have an arrow that is going in the opposite direction. Right, so it's going to go this way. And how far is it going to go? It's going to go 12 steps. So you might see how it's going backwards, negative 2, 1, 0. I'd like to just kind of think about this point right here when it gets to 0. And then it's going to keep going. How far? Right? And here's where I'd like to stop and think. how far did it take for us, this arrow, to get from here at 7 back to 0? How far was that? Well, 7. That's the additive inverse. Gets us back to 0. And then we're wondering, how much farther does the arrow have to go? Well, imagine I had 12 and I take 7 steps away. That's these steps right here. Right, I took off 1, 2, 3, 4, 5. Oops, I kind of messed that up. 7 steps. What's left? And the answer is 5. And that's what's going to happen here. I have 1, 2, 3, 4, 5 steps left in this arrow. Right, there's my 7, and there's the 5, the 7 and the 5, and together they make the arrow of 12. And we want to pay attention to where it ends. And it ends, of course, at -5. How did we get there? Well, it turns out that when we add a positive number and a negative number, they're going in opposite directions. So I can't bind them together or add them together. What I end up doing is subtracting. Right? That's what happened right here. Boom, 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 boom. I started with 7, and I took away 7. Well, I should say, I'm trying to draw this large arrow of 12, right? And I took away 7. That got me back to 0. That's where the positive numbers ran out. And I had 5 left for the negative side. I had 1, 2, 3, 4, 5 left. So when the signs are going in opposite directions, we need to subtract the larger number from the, subtract the smaller number from the larger number to see what's left over, or to find the difference, right? To find the difference. Let's take a look at one more example, and then we'll write down our rule. Adding with opposite signs. All right, let's try a -4. -4 plus, let's try +9. Right, so we'll start at 0. We'll draw our first vector to the left because it's for a negative number, -4. And then we're going to draw an, oops, wrong color there. And then we're going to draw the other one in the opposite direction. So let's start that again. Here's our vector for -4. And here's our vector for 9. So again, I'm going to think about an arrow that's 9 steps long, but I want you to pay attention to these first 4 steps. They only get me back to 0. They get me back to 0, and now's when I really start counting. Right? I have 4, 5, 6, 7, 8, 9. Right? Those are my 4 steps back. How many steps were left before my vector ran out, right? So I'm going to take that large 9 steps. I'm going to take away the first 4. I'm going to take away the first 4 and see what's left over. Turns out that it's 5. And that landed it in the positive direction. Okay, so again, we were subtracting. When the arrows went in opposite directions, I had to subtract that part of it and see what was left in the positive direction. I took off all the numbers that got me back to 0, and then I thought about what was left. So what's our rule? Right? How can we articulate this and turn it into a simple, memorable rule? It goes like this. Okay? When the signs are different, or going in opposite directions, we're going to find the difference. So E, if the signs are different, find the difference. Now this is counterintuitive because you're adding, right? And then all of a sudden you have to subtract. Don't think of it as subtraction. Think of it as finding the difference. And there's a little mnemonic there. When the signs are different, find the difference. And then what we're going to do is keep the larger sign. And what I mean by the larger sign is the larger magnitude, right? Whichever arrow has the larger magnitude. So if we go back and take a look at this little picture here, we'll see that, right, -4 got us into the negative zone. But this -9 was big enough to get us back to 0 and then had some left over to go in its own direction. This was a positive number, so it's going in its own direction. Let's take a look at the previous one, right? Here was our red 7, but the white 12 was bigger. It had enough to get us back to 0, right? Follow this line. It got us back to 0, and there was some left over to go into the negative direction. Because 12 was negative, it got us back. It got us back to 0 and then kept going into the negative zone. There were 5 left over for the negative zone. All right, so that's our simple rule, right? If the signs are different, find the difference and then keep the larger sign. All right, that's it.